Okay, ladies and gentlemen, as you know, I'm in a meeting down the hall. So right now we're on page 196. From time to time, I will stop talking, but the recording is going to continue. That just gives you time to answer a question. So we should all be on page 196 by now. If not, the substitute teacher can hit pause until we're there, because here we go. Two variables can have a strong relationship with one another, as seen in the scatter plot. What's a scatter plot look like? Well, here's our two scatter plots. The one on the left has a weak relationship, not because it's going down, but because there are a whole bunch of points on one side of the line and a few on the other. It is weak. Now, how can you tell mathematically if it's weak or if it's strong? Well, that's the point of today's lesson. This one on the right has a strong relationship because they're well balanced. They're offset by each other. That point is offset by that point. So it's not the strongest it can be, but it is strong. So it could have a strong relationship, but it might not be a causal relationship. Causal. Tell the person next to you what causal means. Causal. And back on me in 5. Okay, so causal means that one causes the other. All you had to do was say the change in one variable causes the change in another. So, for instance, there are lots of things that are causal. Think of one thing that caused another. I was bad at home last night, therefore I was not able to eat dinner. That might be a little bit old-fashioned. Go to your room without dinner. So why don't we say, I was bad at home last night, so my cell phone was taken away from me. That's a cause and effect. That's a causal relationship. In each of the following scenarios, two variables are given that, if plotted, they have a strong correlation. A scatter plot where the data falls nearly in a line. Determine if there exists a causal relationship between the two variables. If so, which causes the other? Is there a causal relationship? Does a high temperature cause the number of bottles of water sold in New York City? Yes. Yes, there is a causal, and the temp causes the amount of water sold. You try number 2. Don't write it down, just think about it. Talk to the person next to you. On me in 5. Okay, does your height cause your shoe size? Let me see. I'm going to measure how tall you are. You're 5'10". That makes you shoe size 10.5. Of course not. Does the person's shoe size make their height? You have a size 7 shoe, so you must be 5'2". No. There is a relationship, but there's no cause. Let's look at the next one. A person's weight loss, and let's not say the number of hours, but the number of hours exercising in the gym per week. Yes, there is a relationship. Yes. The hours cause the weight loss. Make sure you're writing all this down. If I'm going too fast, just hit pause. Years of education a person achieves in the salary and the salary the person starts upon entering the workforce. I'll give you 10 seconds. Yes, there is a causal relationship, and the education causes the salary. Now, variables have extremely strong correlations, but no causal relationship. This is often the case if there's a third variable that causes both, known interestingly enough as a lurking variable. So what are we talking about here? We're saying that there can be what appears to be a cause and effect. Looks like that one thing causes the other to happen, but they really don't. It's something else that might cause one, cause the other, or cause both. That's a lurking variable. The table below shows the number of firefighters required to fight a given fire versus the dollar damage done to the house by the fire. Let's take a look at this. Interesting. Hmm. 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 Looks like I have more firefighters. There's more damage done to the house. Well, that's not good. So the table below shows the number of firefighters required to fight a given fire versus the damage done to the house by the fire. Well, hey, please, only send 2 firefighters because then there's not going to be very much damage to the house. Really? If there's only 1 person that shows up, it's going to be not very much damage. Maybe if 0 people show up, there's going to be no damage. No, not at all. Are the data positively or negatively correlated? Positively correlated. As one goes up, the other also goes up. Positively. Because as one goes up, the other goes up. Now what we should write down also, something down here like side note. Just on the side, it's important to know negative is as x goes up, y goes down. It's a negative correlation. Question B, does the number of firefighters cause the damage done to the house? No. So what's the hidden variable causing both variables to change? Let me see. The size of the fire. If there is a big fire, you think you're going to have a couple of fire departments going, or maybe call out 3 or 4 trucks? Yes. The size of the fire. Size of the fire causes the damage. The size of the fire causes the number of people, firefighters, that you're going to call to the fire. Okay, now let's turn the page. What we're going to be doing is we're going to be doing some bivariate data analysis. We are going to find the equation for the line of best fit. We're going to find the equation for the line of best fit. We're going to find the equation for the line of this data that best fits the data. And then we're going to find out if it's a strong correlation or a weak correlation. We're going to use our calculator to do that. Same thing we've been doing, except the last set of keys is going to be a little bit different. So We hit the stat key, write this down. We hit the edit, write it down. We enter the data. After entering the data, we hit the stat key again. Then we hit calc. Choice 4 says linreg, linear regression, because this is the line of best fit. Lin, line, regression. We're going from the answer to the question. Now, you have all those written down because I'm moving on. I thought. It appears the computer has frozen. Okay, the computer froze for a few moments. So, a survey was done at Ketchum High School to determine the effect of time spent on studying and grade point average. The table below shows the results for 10 students that are randomly selected. Number of hours, let me see, the hours are going up, it's from least to greatest. And the GPA. Okay, this is the X variable. Time is always X. Time is always X. Okay, now it asks us to create a scatter plot for the data on the grid provided. Let's wait a moment. You would plot the 2 and then the 64. You know, the 2 hours, 2, 4, 6, 8, 10. The 2. And then 64, right about there. We're not going to do all of them. I'm only going to do that one. You are going to do all of them when I cut you loose. Now, determine the equation for the line of best fit. That's what I'm going to tell you how to do. The equation for the line of best fit. You hit stat, edit, enter these numbers. This line is going to be in L1, or the first column, all the X's. This line is going to be in L2, or all the Y's. So I am not going to use the same numbers. When I hit stat, I hit edit, the first set of numbers, all the X's go in here. The second set of numbers, all the Y's go in there. Once you have the numbers in there, make sure that the bottoms line up. The directions say hit stat, calc, choice 4. Stat, calc, choice 4, linreg. Go all the way down to calculate and hit enter because that wants us to calculate the answer. And this is what we have. The equation for the line of best fit. That looks like an equation. That's an equation. That's an equation. That's, oh, they're all equations. This is the equation of a line. Okay. But there are no numbers in here. Oh, it tells me what A is. So I can write Y equals. It just says round the slope to the nearest tenth. The y-intercept's the nearest whole number. Okay, so y equals, what's the slope? 0.45x, a is 0.45, plus b, 4.7. So y equals 0.5x, because it says round the slope to the nearest tenth, and the y-intercept to the nearest whole number, plus 5. That's the equation for my line of best fit. I didn't use your data. I use my data. Sorry, I hope you didn't write that down. That's just how to write it as off of the information given. That's not for your data. What I want you to do is I want you to use your data to find the equation of the line of best fit. You're using these numbers. Now, one more thing. I want you to say here, is there a causal relationship between the two variables? The causal will be this number right here. If it's really close to 1, there is. If it's not close to 1, like, let's say 0.78, then that's a no. Okay, but a 0.97 or a 0.98, that's a definite yes. Okay, so that's all I wanted to say for right now. If you have any questions, make sure you ask the substitute teacher, or you can ask me on Monday. Make sure that you finish all the work, including the assignment that they're giving you in class. Catch you later.